previous last two classes, right, we talked about supervised and unsupervised learning. You remember that, right? We talked about reinforcement learning. We talked about all those classifications, right? What supervised learning means, unsupervised learning means. Uh, and then and remember I said supervised learning means that you are actually telling the system what the correct answers are, right? And I give an example of you trying to train a dog, right? In trying to train a dog, or you're trying to train a little baby to have them understand what the difference between a dog and a cat. So, for example, you have to give them pictures and tell them this is a cat, this is a dog. And we say the supervised machine learning model actually tries to model the relationship between two variables, right? By fitting a linear equation to a training data. We can say between two or more variables actually, but in this particular case, we are looking at two variables. And when we say variables, we're talking about things that can change, right? So, for example, you would have had something like this. Does anyone remember what this is? Look at it very well. It might not look exactly like the same letters you used, but this is something that should be familiar. Do you
What are
still
you trying
remember?
to show us?
Oh, can you see this equation?
Yeah.
Yeah. Do you remember what this equation could be? Remember, this is like the equation of a straight line. Do you remember that?
Yeah, sorry, people are having trouble unmuting.
Okay, yeah. So this is like the equation of a straight line where you have m is your slope and c is your intercept. Are you familiar with this equation? Yeah, remember if you try to do something like this, right? That's what the equation gives you, right? So if you have a straight line like this, it's represented by this equation, right? And which is essentially the difference between y. In other words, let's assume this is y2 and this is y1. Remember, this is your y-axis, right? If you go from this point to this point, this is your y1, and this point is your y2. So we can take, let's assume the distance between here and here is like 4, right? So that's your difference in y. So which could potentially have been, let's say this is 1 and this is 5. That will be 5 minus 1 will give you y. And then to get the delta x, you would come here. It's the difference between here and this point. That's what will give you your. So with this, you can get your m, right? So you go your y is equals to m, which is your slope, x plus your intercept. What is your intercept? Your intercept is anywhere this line crosses the y-axis. Does that make sense? Yeah, but I want to assume you have seen the equation of a straight line because that's very important to everything we are going to be doing eventually, right? So just look at it, familiarize yourself with it. So I go back to the previous slide. I'm saying a supervised machine learning model tries to model the relationship between two variables by fitting a linear equation to training data. So what happens usually is they might ask you, right? Go take um, what would I use as an example? So you go take um, someone. Um, let's say you go take the height of people in your class, right? You know, or you go take their age or whatever it is that you take, right? And then you look at their scores, right? Let's say there are 10 of you in the class right now. I write your age and I write your score for this class, your final score for this class. I take your age and I write the score. I take your age and I write the score. I take your age and I write the score. It could be any number of two things that you're trying to calculate, right? You get one of it, which is your dependent variable, and the other is your independent variable, right? You get both of them. So those two things are like your x and your y. And then you try to plot them along this line. right? At the end of the day, when you try to plot it, it will be like dot, 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 and the dots will be all over the place. And you try to place a straight line through those dots. And where you place that straight line is the point where most of the dots go through, the most number of dots can go through that line. And that's how you get your straight line. So even though the dots might just be, say, 10 dots, which is 1, 2, 3, 4, 5, 6, 7, because some of them might not be on the line, but all of them will be close around the line, right? You get those 10 lines. What this means is that with extrapolation, right, I can predict, even though the line doesn't get up to this point, but I can reasonably get to this point, even though there is no dot around here, and I can predict when X is this value, this is what Y should be. And what I describe right now is essentially how machine learning works, right? So this is the simplest form of machine learning. So this line that you have created here is what you would call a model. Does that make sense? Yeah, because what you're trying to do is to create this model